What is going on, team? It is your friend Austin here in AP Space, and today we're going to develop the I2C Direct Memory Access Loopback software. So to begin, we are going to review the schematic, and I want to add this to the video to make sure you guys have the hardware solution in the video, so that there's no confusion on what hardware we're using. And this is the full schematic of the hardware we're going to be developing software on today. So, and scroll to the last page. That's the last page there. And then we need to go to QMX. With another instance of QMX here. And what we want to do is File, New Project. Here was it STM32F722RET6. So yes on that. And then we generate new projects. We then go to File, Save Project As, and we'll just save this in the Photon1 V1 I2C DMA Loopback 4 folder. Click Save on that. We go to System for Sys, Debug, JTAG5 Then. Go to Productivity, go to I2C1, go to I2C. We enable both interrupts. We add the DMA. I2C1 is going to go transmit, and then the rest of the DMA settings can remain as default. We go to I2C2, enable I2C2. We enable with the interrupts. Go to DMA settings. Go to add. We set I2C2 to RX, virtual receive port. Then we can keep the DMA settings as default there as well. We want to set our clock to the 216 megahertz. Set to that. There's nothing else we need to edit on the clock configuration. Configuration should be all set. Just the default pins is fine. I2C1 aligns with PD6 and PD7 on the schematic. Check. Scroll up to the microcontroller. I2C1 and I2C1 goes to PD6 and PD7. I2C2 goes to PD10 and PD11. That aligns with our pinouts. And project manager. Select MDK-ARM for toolchain/IDE. Save the projects. And that should be fine. Generate the code. Projects. And what I'd like to do is fast track you guys and copy and paste the code from our previous projects here. Okay. So what we're looking at first is user code begins 0. So we want to copy and paste all this jazz over to the code 0 section, and we have our variables, or our array variables, we have our counter variables, and we have our receive I2C callback function, and we have our I2C receive direct memory access receive function. So that is both implemented in user code begin 0. We then proceed to user code begin 2. Then we want to copy and paste the code here. And this is just doing receiving 1 byte of data and transmitting 1 byte of data outside of the while loop. And then we go to our while loop and we copy and paste our transmitting the data. And then we have everything we need as far as the code is concerned. We go to projects, we go to options, go to options, under projects, options, and then you go to use default compiler version 6. Select OK. Once that is all set, we can save all there. Then build. We have 0 errors and 0 warnings. And then we download the code. Then go to debug, reset, span bar. All stack plus locals window. And then we want to highlight array 0 RX. We want to add this to watch 1 after we highlight and right click. Then we expand this, and then we run code. Then we have the I2C transmitting port, transmitting the data to the received port, and the received port is receiving the data as expected, and we are seeing AP space 1 in our RX array. And the board we are using is this board, and we have 2 wires plugged in on our I2C port going from one connector on the board to the other. And then we have our JTAG programmer plugged into J3. So this is the board we're using, and this is all the connectors on the board. That's how you develop the I2C direct memory access software on STM32F7, and you guys all have it.